On this last problem, number 9, we're asked to verify an identity, which means we're going to prove it. So, which side to use? Now, this one is very interesting because this side looks really complicated, but this side is the one that we actually have an angle that's messed up. So usually I say you want to take a look at that. Also, notice that we're in the power reducing half angle formula section. So notice this has a power reducing and half angle kind of thing to it. So I would start with the left hand side. So I've got sine squared of theta over 2. And I don't like having these weird angles. So I'm going to go to my half angle identities, which you can see here. And this first one, it turns it into a square root. Now the cool thing about it is if I take a moment to notice, what we're starting with is sine squared. So we would actually be squaring this whole radical and thus making the radical go away. So I definitely know that that's probably where I want to get started. So I'm going to go ahead and change this to the square root of 1 minus cosine of theta all over 2. And that whole thing is squared because sine was squared. So now I've got 1 minus cosine theta all over 2. And somehow I've got to change that into what we've got going on up here. So at first glance, these two things look very different. However, if you notice, the only thing new in the denominator is a cosecant theta. And if we just try it out and see what happens if we multiply the top and bottom by cosecant, I think you'll be surprised at what we get. So I'm going to multiply by cosecant of theta on top and on bottom. So I'm not changing the value of anything. And at this point, my denominator is perfect, so I'm not going to mess with it. The numerator is what I want to mess with to get it to look like this. So I'm going to go ahead and distribute. And now I've got cosecant of theta minus cosine theta times cosecant theta all over 2 cosecant theta. So now I've got two parts that look like the right hand side. Now I just need a cotangent. And the thing is, if you look closely at this part, cosine is fine. We want that to be on top for cotangent. We would really like for this cosecant to turn into a 1 over sine. And in fact, that's what it equals. So over here, I'm going to write this whole thing equals cosecant theta minus cosine theta over sine theta all over 2 cosecant theta. And I was able to do that because of the reciprocal identity. I haven't been using my reasoning over here. I usually do that at the end. So this is my half angle. This is simplifying. We just canceled the root. Here we multiplied on top and bottom. Down here we distributed. Up here we use the reciprocal. And lastly, we're going to use the quotient to change it into cotangent. And we're done.